Hi, and welcome to this section of the Basic Math Word Problem Tutor, where we're going to continue working with fractions. But in this section, we're going to deal with fractions, dividing fractions, okay, in the word problems here. So the good news is, and it's very good news, is that if you go back to the section on multiplication of fractions and the word problems there, and if you can do that, which I think by now you can, then this section is going to be very easy, okay? Because just like anything else in life, if you learn the basics and start building on it, then the next topic and the next topic and the next topic come that much easier, okay? So just think about it. Once you know how to add two numbers together, subtraction isn't that big of a deal. It's the opposite of addition. Same thing with this here. When you know how to multiply fractions, I'm going to show you here that division of fractions ends up being multiplication. So I'm going to show you how to divide fractions and using the skills that we gain by reading the word problems. But in the actual math itself, I'm also going to show you that division of fractions is nothing more than multiplication. I'm going to show you that. It's going to be very easy, and you're just going to end up doing a lot of multiplying here, even though it's actually division, and that's the title of this section. So the easiest way to do it is just to jump right on in like we always do. The question is, you have 1/2 of a pie on the table. If you split the pie, or the half of a pie that's there, between two people, how much pie does each person get? Okay, so that's the question. So what you're doing here is you have half of a pie on the table, okay, you have this much pie, and you're splitting it, which means you're dividing it by 2, right? Because there's 2 people, you're splitting it, and you're dividing it by 2 between 2 people, and you want to see how much each person actually gets, okay? So this is clearly division because you're given some piece and you're splitting it between some number of people, so you're dividing it into an equal number of pieces, okay? So don't let the fact that this has a fraction in it confuse you. Just because there's half a pie on the table doesn't change the fact that you're taking that and you're splitting it between 2 people. So what you're doing is you're taking that 1/2 of a pie and dividing it by 2. And so that's what we're going to do, and we're going to write it down exactly like this. You have 1/2 of a pie, okay, and you are dividing it by 2. Okay, so notice what I'm doing here. I've got my 1/2 up here, and I've got a very long division bar, which, by the way, fraction is the same as division. So I've just got a big long division bar, dividing it by 2. Okay, so that's what I like to do here. I like to write it like this. You can also see this a lot of times. You'll see this on your test, divided by 2. You'll see it like this. Okay, 1/2 divided by 2. You'll see it like this a lot. But this is exactly the same thing, and I want you to learn how to look at it that way. It'll make your life easy. Okay. You're taking this number and you're dividing it by 2. Okay, now the question is, how do you go from here? What do you do next? Well, in order to divide fractions, just like in the adding and subtracting and the multiplying of the fractions, I said let's take every number and let's make it into a fraction before we actually do any addition, subtraction, multiplication, or division. Here we have a 2 on the bottom, and we're dividing by 2. Okay, so this 2, I want to make it into a fraction because then it's going to be easy. So I'm going to have 1/2 divided by 2 over 1. Okay? That's what I'm doing. 1/2 divided by 2 over 1. Okay, because 2 over 1 is equal to 2. Okay? So, now here is the magic. Here is the beauty. Here is why it's easy. Okay, I'm going to show you something. Anytime you have a fraction divided by another fraction, all you do is take this fraction, flip it over, and multiply it by the top. And that's why division becomes multiplication when you're talking about fractions. So what you would do is you would take your 1/2 and you would multiply it by 1/2. Because this 2 over 1 flips over, becomes multiplied with the top. And that is what we're doing here. Okay? So make sure you understand that, because this is the central point to this entire lesson. You must understand this. When you take a fraction and you divide it by another fraction, all you do in order to actually do this division is you turn it into multiplication. So you take this bottom fraction, you flip it up, you can kind of see this as almost like a handlebars or some kind of a gym set or something. This thing on the bottom flips up over and becomes multiplied by the top. And then once you do this multiplication, you have arrived at the answer of what you're trying to do, which was divide. So in fractions, it becomes multiplication. We already know how to multiply, so that's why I said this section was going to be easy. 1 times 1 gives you 1. 2 times 2 gives you 4. So the answer is 1/4 of a pie. Each person gets 1/4 of a pie. Now don't forget what we had. If this was your pie, on the table, 1 whole pie. Okay, what we had to begin with, we said we had 1/2 of a pie. This half is all we had on the table. And then we divided by 2. So if you have this much pie available and you divide it by 2, and each person gets half, okay, then in the end, all I'm going to have is this. Okay? All I'm going to have is this, because if I take this and I chop it into 2 pieces and I give this piece to my friend and this piece to me, okay, then I'm only going to have 1/4 of this pie, which is this. So you take 1/2, you divide it by 2, and you arrive at this, and that's just equal to 1/4 of the pie. Okay? So we're going to do a lot of these, and you're going to get a lot of experience with it. This little trapeze act that happens here is going to happen over and over again, and this is why I wanted you to write it like this, rather than writing it like you see it a lot of other times. You'll see this a lot of times. And this is exactly what you're doing. You're dividing by 2. But when you write it like this, 1/2 divided by 2, it's very easy to visualize this flipping over stuff, which is what you're going to do every single time in every one of these problems. Every one of them, okay? So the next question says, to get more practice with this, a board is 15 inches long. 15 inches long, okay? If you cut the board evenly into pieces 3/4 of an inch long, how many pieces do you have? Okay, so you have a board 15 inches long, and what it's saying is you're cutting it, you're chopping it up into pieces that are each 3/4 of an inch long, so less than 1 inch, 3/4 of an inch. So I have one piece here, I'm cutting it up into another piece, into another piece, another piece, another piece, and I do it all the way till I get to the end. How many pieces do I have? So what you're doing is you're dividing, see, that's how you know you're supposed to divide here. You're dividing this board into pieces that are 3/4 of an inch long. So you're taking your 15-inch board and you're dividing it by 3/4 of an inch, and then you'll see how many pieces you have. Okay, so let's do that. We're going to write this the same way as the other one. We have a board that's 15 inches long divided by 3/4 of an inch. Okay, 3/4 of an inch. And notice I wrote the top number and then a long bar, which is divided by, and then the bottom number. Now the first thing we need to do is change this 15 into a real fraction, okay? Because then we can do our business here, and we can change this into 15 over 1 divided by 3/4, okay? We can do that. Because any number can be written as itself over 1. We've talked about that many times. So now you have a real fraction over a real fraction, and we said that any fraction divided by any fraction is just simply going to be, you take the bottom one, you flip it over, and you multiply times the top. So it's going to be 15 over 1 times 4/3. Okay, so you see we did our little trapeze act. We took our bottom fraction, we flipped it over, and multiplied. So that's what we did here. So we turned our division into a multiplication, which we already know how to do. And that's good news, okay? So, top times top. What is 15 times 4? Well, if you don't remember what 15 times 4 is, you can just do it real quick. Okay? 15 times 4. 5 times 4 is 20, so I'm going to put a 0 and carry the 2. And 1 times 4 is 4, plus 2 is 6. Okay, so 15 times 4 is 60. So 15 times 4 gives us 60 on the top, and on the bottom, 1 times 3 gives us 3. Okay? 1 times 3 gives us 3. So the answer is 60 over 3. But notice that this is an improper fraction, and like I told you before, we always want to try to convert those things when we can. And this is division, just like any fraction is division. So how many times does 3 go into 60? Well, we could do that right here. We could take 60 and we could divide it by 3 and see what kind of a number we get. Okay? 3 times what gives us 6? Well, 3 times 2 gives us 6 exactly. 2 times 3 gives us 6, and then we do our subtraction. 6 minus 6 gives us 0, and then we drop down the other 0. Okay? 3 times what goes in, or 3 goes into 0 how many times? Well, it goes 0 times. 3 can't go into 0 at all. Okay? And 0 times 3 gives us 0. You subtract, you get 0. So you have a remainder of 0 here. So what I'm saying is 3 goes into 60 20 times exactly. Okay? So the answer is 20. Because 60 divided by 3, when we simplify this, gives us our 20. Okay? So the answer is 20 pieces. Okay, 20 pieces. All right, so if we take a board that is 15 inches long and we cut it up into sections that are 3/4 of an inch, we divided by this fraction, and then all we did was we turned the top into a quick and easy fraction so that we could do our division. We turned our division into multiplication by flipping it over and multiplying, and then from then on, it's exactly what we've done before, just simply multiplying fractions. 15 times 4 gives us 60. 1 times 3 gives us 3, and then we simplify this just by dividing, because that is what a fraction is, and we get 20 pieces. So you'd never be able to predict that ahead of time. I don't think anybody would be able just to look at that and say, well, that's going to be 20 pieces. Okay, well, you have to do the math and you have to do the simplifying. Okay. Okay, the next problem says I have 2 1/8 pounds of jelly beans. How many gift bags of jelly beans could I fill if each bag held 1/4 of a pound of jelly beans? Okay. So what you're doing is you have a pile of jelly beans telling you it's 2 1/8 pounds. And I want to fill up these little Christmas bags or these gift bags. And each bag can only hold 1/4 pound. So I'm trying to find out how many bags can I fill if each bag only holds 1/4 pound. So what I'm doing is I'm dividing the amount of jelly beans I have among so many bags. So you can see by the way I phrased it, I'm dividing. Okay. So if I know I have 2 1/8 pounds total, and I divide by 1/4 of a pound, that will tell me how many bags I can fill, because I'm dividing it up among sizes of 1/4 each. Okay, so if I were going to write that down in terms of math, I would have 2 1/8 pounds of jelly beans, and I'm dividing that by 1/4, because I'm dividing it by little baggies that only have enough space to hold 1/4 of a pound. Okay, so I'm dividing to see how many bags I can hold. So the first thing I need to do is change this 2 1/8 to a real fraction with the top and the bottom, and then I can do my little trapeze act and solve a problem. So we're building on our skills. How do you convert this to an improper fraction? 8 times 2 is 16, plus 1 is 17, and you just write it over 8, just like you have here, divided by 1/4. Okay? So we've used this little skill all the way through here. 2 times 8 is 16, plus 1 is 17 over 8. And then you're dividing the whole thing by 1/4. Okay, now I'm ready to do my trapeze act. When you have a fraction divided by another fraction, you just take the bottom one, you flip it over, and you multiply. That's all you do. So you have 17 over 8 times 4 over 1. 4 over 1, because I flipped it over. Okay, now I turned my division into a multiplication. Okay, so to get the top number in the answer, what is 17 times 4? Well, I certainly don't remember what 17 times 4 is, so I'm going to have to multiply that out. Okay, 7 times 4 is 28 from your multiplication table, so you put an 8, carry the 2. Okay, 4 times 1 is 4, plus 2 gives you 6. So the answer is 68 on the top, and because 17 times 4 gives me 68, and then on the bottom, 8 times 1 gives me 8. Okay, so here is the answer: 68 over 8. That is how many jelly beans I can fill. Okay, but the question is, can I simplify that anymore? Well, this is an improper fraction. It has a bigger number on the top than the bottom, so I want to try to convert that. And I want to do that by actually doing this division. 68 over 8 is the same thing as 68 divided by 8. So let's convert that. Let me ask you a question. How many times can 8 go into 68? Okay, well, let's go ahead and try. 8 times 7 is 56, so that's getting closer. 8 times 8 is 64, okay, that's very close. And 8 times 9 is 72, okay, so that's too many. So it definitely does not go 9 times, it only goes 8 times, okay? But 8 times 8 only gave us 64. This is pretty close to 68. What's the difference between 68 and 64? Well, that's a difference of 4, and we write it as 4 over 8, like this, okay? So make sure you understand this. 8 goes into 68 only 8 times, because 8 times 8 is 64. That's pretty close to 68. But I have some left over. In order to find out how many I have left over, I say 68 minus that 64, okay, is how many? Well, that's only 4. So I write it as 4 over my fraction, 8. That's how we always convert improper fractions to mixed fractions, okay? Now, you have to ask yourself, is this in simplest form? Is this 4/8 in simplest form? Can I divide the top and the bottom by a number to make this simpler? And the answer is yes. If I divide the top and the bottom by 4, let's see what happens. 4 divided by 4 is 1. 8 divided by 4 is 2. That is simple form. So I can fill 8.5 bags. So you see, it's very useful stuff. I have 2 1/8 pounds of jelly beans, and I'm trying to fill each bag that has, I can hold a 1/4 pound in each bag. I can fill 8.5 bags doing it this way. So I have 8 full bags, and I have half of the other bag full, and that's how you do that. So you see, each time we're doing this, we're getting a little bit more practice with a little bit more difficult problem, but in all the problems, they're really similar. You are dividing a fraction by another fraction, you get them into fractional form, you flip the bottom over and multiply, and then from that point on, you're just using the skills that you have from your multiplying fractions, because division of fraction is multiplication. So the next problem says you're walking at a speed of 2 1/4 miles per hour. Okay, how long do you need to walk in order to go 10.5 miles? Okay, now these types of problems usually give students problems because it's very difficult to know if you're supposed to multiply or divide here. You know you're not going to add because you've got miles per hour in miles. So you're not going to add miles per hour plus miles or minus miles. That just doesn't make sense. In order to add or subtract numbers, you have to have the same units. But multiplying and dividing sometimes gives students problems. There's 2 ways to tackle this. The first way, let's just think about it logically, and the second way will be units, okay? So the first way, I'm walking at 2 1/4 miles per hour. That means that every hour I go another 2 1/4 miles. So I go 2 1/4 miles, the next hour I go another 2 1/4 miles, next hour I go another 2 1/4 miles. How long does it take for me to walk 10.5 miles? So I want to walk this far, which is 10.5 miles, let's say. First hour I go 2 1/4, next hour 2 1/4, next hour 2 1/4. So if I were to divide this 10.5 miles I'm trying to go by 2 1/4, I would find out how many hours it would take me to do that because I'm going 2 1/4 miles per hour. So that is the logical way to think about it, just by thinking through what it's doing, which is important. But even if you had no idea how to do that, you can still figure out how to solve this problem just by using your units. So let's do that. The problem says that I need to walk 10.5 miles. Okay? I'm going to write that down. I'm going to draw my little line like I've been doing. Okay? The next part says I'm walking at 2 1/4 miles per hour. Now, if I write it as 2 1/4 miles per hour, so I write it miles per hour like this, what would happen? Well, what's going to happen is because I have miles on the bottom and miles on the top, this cancels with this. And the units of what I would be left over with is just going to be hours, which is what I want because the question says, how long do you need in order to walk this far? Okay? So what this is telling me is that division is the right way to go. 10.5 divided by 2 1/4, that's going to give me the number of hours. That's what we said we should do to begin with. Now, if you had screwed this up and wrote this as 2 1/4 miles per hour, so you had miles per hour, you would get nowhere because none of the units would cancel. You'd have miles per hour, miles, miles, and hours, and none of those units would work out. You would not end up with hours. So you would know you should not multiply these two numbers together because that's not going to get you what you want. Units are very, very powerful. So what this is saying is I want to divide these two numbers. So now I know I need to take 10.5 divided by 2 1/4. That's what I want to do. Okay? The first order of business is to take this top mixed fraction and convert it to an improper fraction. 2 times 10 gives me 20, plus 1 gives me 21, over 2, because we just keep our little denominator, divided by, or over, I draw a big long line here, okay, which is this one here, and we're going to convert this one. 4 times 2 is 8, plus 1 gives me 9, over 4. So this fraction we converted to this one, and this fraction we converted to this one. And now we can do our little trapeze act, turning this division of two fractions into multiplication. You just take the bottom fraction, flip it over, and multiply. So we have 21 divided by 2 multiplied by, flip it over, 4/9. Okay, so we've turned our division of fractions into a simple multiplication problem, which we know how to solve. So to get the top number, it's going to be 21 times 4. And if you don't remember what 21 times 4 is, you just multiply. 4 times 1 is 4. 4 times 2 is 8. Okay, so it's going to be 84. So 21 times 4 is 84 on the top. And for the bottom, you just take 2 times 9 from your multiplication tables. This is simply 18. So the answer you get is 84 over 18. And in order to finish the problem out here, this is the answer. This is how many hours it takes. But you really need to convert this to a mixed fraction, and then it makes more sense and it looks nicer. So the question is, how many times does 18 go into 84? Okay, how many times does 18 go into 84? Well, let's just see here. If we say, let's just work something over here. Let's say we try to make it go in 3 times. 18 times 3, what does that equal? 8 times 3 is 24, so I'll put the 4, carry the 2. 3 times 1 is 3, plus 2 is 5. So that gets me to 54. That's not close enough. Okay, the next thing we're going to do is try to multiply by 4 and see how much closer we get. Okay, because we're trying to see how many times 18 can go into 84. So doing this, 8 times 4 is 32, so we put a 2 and carry the 3 for 32. 4 times 1 is 4, plus 3 is 7. So 72 is about as close to 84 as you're going to get without going over. Okay, so the answer is this goes 4 times. Okay, it goes 4 times, but that only gets me to 72. Okay, we have to find the difference between the 72 and the 84 in order to finish the problem out. So in order to do that, we just take the 84 minus the 72, and then we see where we go. Okay. So 4 minus 2 is 2, and 8 minus 7 is 1. So I only have 12 left over, and I write it over 18. Okay, so that was a lot of extra math, but what it means is I go 4 and 12/18 hours, and before we get too anxious here to get the final answer, we should always ask ourselves, can we simplify this at all? Can we divide the top and the bottom number by something to make it simpler? And the answer is yes, we can divide top and bottom by 6. 12 divided by 6 is 2. 18 divided by 6 is 3. So the answer is 4 2/3 hours. Okay, so if I am traveling a distance of 10.5 miles and the speed that I'm going is 2 1/4 miles per hour, how long will it take me to do that? When I divide them, I get 4 2/3 hours, which is almost 5 hours. So what we did is we took the 10.5 divided by 2 1/4, converted our mixed fractions into our improper fractions, and we flipped it over and multiplied. Okay, top times the top gave us the 84. Bottom times the bottom gave us the 18. And then from here on out, it was just a matter of converting that back to the mixed fraction. So we tried to find out how many times 18 goes into 84, and we found out that it only goes 4 times because 18 times 5 is too many. You'll bust that. 18 times 5 is just going to be too many. So it goes 4 times, and then you have to find out what the remainder is. So we know that if it goes 4 times, it only gets us up to 72. Take the 84 minus the 72 gives us 12. So it's 12 over 18 right here. And then we simplify this fraction here by dividing top and bottom by 6. And that gets us down into the simplest possible form we can get. So again, I want to stress, this is an answer. This is the answer. It's just not in simplest form. This looks a whole lot better because it's a little bit easier to read. 4 2/3 hours. Okay, the next problem says, every squirt of a squirt gun shoots 1 3/4 ounces of water. How many squirts does it take to fill a 6-ounce bottle? Okay. So I have a squirt gun, squirt, squirt, squirt. Every time I squirt, 1 3/4 ounces comes out of the gun. Okay, and I have this bottle here, and I'm trying to fill it up to 6 ounces. How many squirts does it take? Okay, so you see what you have here is what you're really doing is you're dividing the 6-ounce bottle, and you're trying to divide into it 1 3/4 ounces. Because if you take that bottle and you divide it by 1 3/4 ounces, then you'll find out how many squirts it takes to fill it up. Because if here's a bottle, after 1 squirt, it goes 1 3/4 ounces, and after another squirt, it goes another 1 3/4 ounces, and after another squirt, it goes another 3/4 ounces. So if you divide the 6 ounces by 1 3/4, then you'll know how many squirts it takes to fill it up. But even if you didn't know that, even if that logic just didn't even hit you, you can always use your units, okay, to figure out what to do, okay? Okay, so what we're going to do is we're going to take our 6-ounce bottle and we're going to divide it by 1 3/4 ounces. That's what we're doing here. Because we know we have 6 ounces to fill and we're dividing it by each squirt is 1 3/4 ounces. So by dividing, I'll know how many squirts it takes, okay? So on the top, I need to make him into a fraction. The easiest way to do that is just 6/1. And on the bottom, I need to make him into a improper fraction. So I do that by 4 times 1 is 4, plus 3, starting with 4, 5, 6, 7, gives me 7, and I just write it over 4. Okay? So I turned him into a real fraction and him into a better looking fraction. And now I can do my little trapeze act. Since I'm dividing fractions, I take my bottom fraction, I flip them over, and I multiply. So it's going to be 6/1 times 4/7. I take the bottom, flip them over, multiply. Okay. Now on the top, I'm going to have 6 times 4 gives me 24. Okay. And on the bottom, 1 times 7 gives me 7. So on the top, I just multiply. 6 times 4, 24. Bottom, 1 times 7 is 7. Okay. So the question is, what do I do next? I need to try to convert this. This, by the way, is the answer, the 24/7. That is the answer. But you want to try to get him into a better form. So this is an improper fraction. Let's go ahead and convert him back into a mixed fraction and see what we get. So how many times does 7 go into 24? 7 times 2 is 14. 7 times 3 is 21. That's very close. 7 times 4 is 28. That's too many. So he definitely doesn't go 4 times. He only goes 3 times. 7 times 3 goes 21, so he goes in 3 times, but there's something left over. What is the difference between 21 and 24? The difference is 3. So you write it as 3/7. Okay? And this is how many squirts you need. So what this is saying is, if you have a 6-ounce bottle, and if every squirt only gives you 1 3/4 of an ounce, you will have to squirt 3 times plus 3/7 of a time. So 1 squirt, 2 squirt, 3 squirts, and in that last one, you don't want to make it a full squirt. You just want to just squirt it a little bit because it's only 3/7 of a squirt, that last one, and that will fill your 6-ounce bottle up. Okay. The next problem is kind of interesting. It says, if you have a water leak under your sink and the rate of that leak is 1/7 gallons per hour, you put a 1.5 gallon bucket under the drip, okay? How long do you have before it fills, okay? So you have a water leak, drip, 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 it's getting water all over the place. And you know how fast the water's coming out because it says it's 1/7 gallons per hour. So this is a gallon, 1/7 maybe like this much, 1/7 gallons per hour. So every hour, another 1/7 of a gallon comes out. Another hour, another 1/7 of a gallon. Another hour, another 1/7 of a gallon. You put a bucket underneath there, but that bucket can only hold 1.5 gallons. Okay, so how long does it take to fill it up? Well, because you know the bucket only holds 1.5 gallons, okay, and because you know the rate of the leak is 1/7 gallons per hour, if you were to divide the 1.5 gallons by the 1/7 gallons per hour, you would find out how long it would take to fill that bucket up. Because you have this much of a bucket, and every hour, 1/7 of a gallon goes in that bucket. And the next hour, another 1/7. And the next hour, another 1/7. And the next hour, another 1/7. All the way till you get the top. So if you divide by how many 1/7 can fall into there, okay, that tells you how many hours it takes to get to the top. But even if you didn't remember that, even if you didn't know that logically, you could still use your units to figure it out. The problem says, you have a bucket that's 1.5 gallons. Okay, that's how much it can hold. And what I'm going to do is, I'm going to see if I need to multiply or divide. And let's go ahead and divide, and let's show you what happens. It's 1/7 gallon per hour drip. If we write it this way, which is division, which is what we know we're going to do, gallons will cancel with gallons, okay? Because they're on the top and on the bottom. So because gallons cancels with gallons, you'll be left with hours. So by dividing the 1.5 gallons by the 1/7, you will be left with how many hours it takes to fill it up. If you had done the wrong thing and put it up here as 1/7 gallon per hour, where the gallons up here per the hour, which would be multiplication, okay, then it would not work out because the units would not cancel. You would not be left with hours. That would be wrong. That's why you do not multiply. So now we know we have to divide. 1 1/2 divided by 1/7. What do we do first? Well, we take this mixed fraction and we convert it to an improper fraction. And to do that, we say 2 times 1 is 2, plus 1 is 3, and we write it over 2. 3/2. Okay, we're still dividing by the bottom, which is still 1/7. So all we did was we took this and converted it to this. 2 times 1 is 2, plus 1 is 3, put it over 2. And we carry the bottom along for the ride. And we're doing a fraction divided by a fraction, so we can do our little trapeze act. Take our bottom fraction, flip them over, and multiply. 3/2 times, flipping this over, is going to be 7/1. And now you see this complicated looking thing is very simple because we know how to multiply those things. 3 times 7 is going to give you 21 on the top, and 2 times 1 is going to give you 2 on the bottom. And this is the answer. This is the number of hours it takes, 21 over 2. But we always like to convert these improper fractions back into mixed fractions. So the question is, how many times does 2 actually go into 21? Well, I think I can convince you that it goes 10 times because 10 times 2 is 20. So it goes 10 times, but that only gets me up to 20. And the difference between 20 and 21 is 1. So the remainder I had was 1, and I write it over 2, which is the answer. 10.5 hours. Okay, so let's review what we did here. We take our 1.5 gallon divided by our 1/7. Convert our 1.5 to this improper fraction. Again, we're dividing by the 1/7. Okay, and what we're doing is we take our bottom, flip it over, and multiply, which is what we did here. And then to actually do the multiplication, it's top times top gives me top, bottom times bottom gives me bottom. This is the answer, but we like to convert it, so we're going to actually do this division. Okay. 21 divided by 2 goes 10 times because 10 times 2 is 20. But since it only gets me up to 20, I have a remainder. 21 minus 20 is 1, so the remainder is 1, and you put it over 2, which is how we always express it in terms of a fraction, so 10.5 hours. Okay, the final problem says your car's gas mileage is 16.5 miles per gallon. After driving 40.5 miles, how many gallons did you use? Okay, how many gallons of gas did you use? So this is talking about miles per gallon and miles. So our units are going to be very helpful here, but before we even get to that point, the car gets 16.5 miles per gallon. That means that for every gallon of gas, every milk jug of gas that it burns, it goes 16.5 miles. So for the first gallon, it's 16.5 miles. The next gallon is 16.5 miles. The next gallon is 16.5 more miles. But we're driving a total of 40.5 miles. Okay, so how many gallons does it take to do that? If we were to take our 40.5 miles and divide it by the 16.5 miles per gallon, that would give us what we need because, you know, if we're driving this far, which is 40.5 miles, after that first gallon of gas, I drive only 16.5 miles. After the next gallon, it's another 16.5 miles. After the next gallon, it's another 16.5 miles. After the next gallon, it's another 16.5 miles. All the way up to the 40.5 miles that I'm trying to go. So if I divide the two numbers together, I'll find out how many chunks of 16.5 gallons I can have there, and that's going to be how many gallons of gas I use. But even if that didn't make any sense at all, and even if you didn't know to think about it like that, okay, you could always use your units. Okay. 40.5 miles. Okay, that's how far I'm going. I'm going to draw my little bars here. Okay, and I know I'm going to be burning the gas at a rate of 16.5 miles per gallon. So if I write it as 16.5 miles per gallon. Okay, miles per gallon. Okay, then if I write it like this, which is division, by the way, because I've got it on the top and the bottom, then what I notice right away is the miles cancels with the miles, okay? Which means I'm going to be left with gallons. And the question says, how many gallons of gas did you use? So by just arranging it like this, I know I must divide these numbers. If I did the wrong thing and had 16.5 miles per gallon, which means multiplication times 16.5, the units would not work out at all. None of the units would cancel, and I would not be left with gallons. This way, I'm left with gallons, so I'm doing the right thing. So I have 40.5 divided by 16.5. Okay, 40.5 divided by 16.5. Okay, so the first thing I'm going to do is convert this to an improper fraction. 2 times 40 is 80, plus 1 is 81, and I do it over 2. Okay, like this. And I'm dividing it by 16.5, so I'm going to convert this. 16 times 2 is 32, and if you need proof of that, 16 times 2, 6 times 2 is 12, carry the 1, 2 times 1 is 2, plus 1 is 3. So 16 times 2 is 32, plus 1 is 33 over 2. Okay? So all I have done here, I know I have to do this division, and all I have done here is convert these fractions to these improper fractions over here. Okay? Now, I get to do my nice little trapeze act. I can take this, flip it over, and multiply. Okay? So I'm going to do that. I'm going to flip it over and multiply. I'm going to have 81 over 2 times, flip this over, 2 over 33. Okay? Okay, now the next thing I want you to notice is something really interesting. Notice I have a 2 on the top and a 2 on the bottom. One on top and one on bottom. What this is going to mean is I can cancel this 2 with this 2. Because 2 divided by 2 is 1, which just means that you can just drop it. Okay? So the same way that I'm doing miles over miles, you can get rid of them. And the same way that you know 6 over 6 kind of cancels because it equals 1. Okay? What you can do here is you can ignore the 2's and just kind of drop them because 1 is on the top and 1 is on the bottom. Because don't forget what you're doing is if you were to just multiply this out, you could do that, 81 times 2, and you could get the top number. 2 times 33, and you get the bottom number. And you have some pretty big numbers there, so you could do that. But by noticing that I have a 2 on the bottom and a 2 on the top, and just by canceling them, then all I have left over is 81 on the top and 33 on the bottom. So I can avoid really doing any multiplication here just because I know that these can cancel out. You can certainly do the multiplication, that's fine, but anytime you have something on the top and something on the bottom of a fraction like this, you can cancel it if it's the same number. So here I have 81 over 33, and I want to convert that to a mixed fraction. So how many times can 33 go in to 81? That is the question. How many times can that happen? Well, let's try it. 33, let's see if it can go 2 times. 2 times 3 is 6, 2 times 3 is 6. So it can definitely go 2 times. What if can it go 3 times? Let's say 33 times 3. 3 times 3 is 9, 3 times 3 is 9. So that's too many, it's too big. It does not go 3 times. But it does go 2 times, which is what we found here. And that brings me up to 66. So there is a remainder between 66 and 81. Okay? So in order to find that remainder, I take 81 minus 66. And I just subtract that. Starting in this column, I need to borrow because 1 minus 6 I can't really do. So I make this an 11, and I scratch through this and make it a 7. That's my borrowing. 11 minus 6, starting at 11, 10, 9, 8, 7, 6, 5. I have 5 left over here, and then 7 minus 6 is 1. So I know the remainder is 15, so I write it as 15, and I always write it over the denominator to make it into a fraction. So the answer is 2 and 15, 33. Okay, so this is the answer, but we always want to try and see if we can simplify it. Is there something that we can divide into the top and the bottom here to make this simpler? And the answer is yes, we can actually divide by 3. 15 divided by 3 is 5, because 5 times 3 is 15. And 33 divided by 3 is 11, because 11 times 3 is 33. So the answer is 2 and 5/11 gallons. Okay, now I really want to retrace our steps here because there's a lot of work here. We knew that we were going 40.5 miles, and we knew we were burning at a rate of 16.5 miles per gallon. So we knew we needed to divide them. We convert this to 81 over 2, because 2 times 40 is 80, plus 1 is 81, and you write it over 2. On this one, 2 times 16 is 32, plus 1 is 33 over 2. So all we did was convert the fractions. And then in order to actually do the division, we did our trapeze. We flipped the bottom over and multiply, which is what we did here, 2 over 33, multiply. But then we noticed that we had a 2 on the top and the 2 on the bottom, which we can cancel anything we see in the top and the bottom of a fraction. So we get rid of it. Okay? We could have done this multiplication and gotten a number, and done this and gotten a number, and simplified. That would have worked too, but I'm choosing to show you something a little different here. Okay? So what we're left with after the 2's go away is just 81 over 33, and then this is the answer. This is the number of gallons, but we want to convert back to a mixed fraction. So then we had to see how many times did 33 go into 81. Okay? It goes 2 times because that brings us up to 66. 3 times is too many. Okay, so that's too many. 99 is more than 81. So it goes 2 times, and we had to find the remainder. When it goes 2 times, it brings us up to 66, and the difference between 66 and 81 was the 15. So in order to write that remainder down, we write the 15 over the denominator, and then that is the answer as well. And we're just going to simplify this by dividing the top and the bottom of this fraction by 3, and we get 2 5/11 gallons. So in this section of the class, we've really covered a lot of material, and we've talked about division of fractions and word problems. And I think you can see by now that division of fractions is really no different than multiplication, because once you put it in the right form, you just take the bottom, turn it over, and multiply. All division of fractions ends up becoming multiplication. And that little tool in your toolbox is going to prove very useful for you, because all you have to do is know how to multiply. And even multiplication isn't that hard. Multiply the tops, multiply the bottom, and you must know how to simplify those fractions. So with some practice, I think you will get good at problems involving division of fractions.